Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the equation of a circle or a semicircle. So let's start with these two graphs here, starting with this one. So because this is a circle, I know that its equation can be written in this form. So remember, the center of the circle is negative a, negative b. So here, the center is 3, 1. So a is going to be the negative of the x coordinate of the circle. I'm going to change a to negative 3. Similarly, I'm going to change b to negative 1. It's the negative of the y coordinate of the circle. So for the radius, you can just count how far it goes from the center to the circumference. So it goes 1 unit in each direction. The radius here is 1. So r is 1, and of course 1 squared is just 1. So this is the equation of the circle here. Now let's find the equation of this semicircle. So I think it's probably easiest if we find the equation as if this were a full circle. So here the center is 2, 1, and the radius is 2. So this would be the equation of the full circle. But remember, a semicircle occurs when we try to make y the subject. So let's make y the subject here. What we're going to do is subtract x minus 2 squared first. So now what we have to do to both sides is square root. Because this is the top half of the circle, we're going to take the positive square root of this side. If this were the bottom half of the square root, we'd put a negative out the front. We'd take the negative square root of this. And now to get y by itself, all I need to do is add 1 to both sides. So this is the equation of the yellow function. Of course, this is not a function, fails the vertical line test. This is a function, it passes the vertical line test. All right, let's now look at some harder questions. So we're going to find the domain and range of the circle with center here that passes through this point. So to do that, I'm actually going to first find the equation of the circle. So because it's a circle and its center is negative 2, 3, I know that I can write its equation as x plus 2 squared plus y minus 3 squared equals r squared. The only thing we're not really told here is what the radius is. But remember, the radius of any circle is the distance from the center to its circumference. Because the circle passes through this point, that means that this is on the circumference of the circle. So let's calculate the distance from the center to the circumference. So using the distance formula, we have x2 minus x1 all squared plus y2 minus y1 all squared. So square root of 4 squared plus negative 5 squared is actually the square root of 41. So the radius here is the square root of 41, which is an irrational number. Of course, the radius doesn't necessarily need to be a whole number. So the number that goes here for r is square root of 41 squared. Of course, if you square root 41 and then square it, you're just left with 41. So that would be the equation of the circle with this center that passes through this point. All right, let's look at one more example. So let's look at this question here. We're going to find the center and radius of this circle here. It does not at all look like the equation of a circle. It's not in the form x plus a squared plus y plus b squared equals r squared. So what we're going to need to do is put it in that form. So when we have x plus a squared plus y plus b squared equals r squared, the normal form of a circle, all the x's and y's are on one side of the equation. So I need to move the 2y squared over here. So now it's starting to look a little bit more like the equation of a circle. But what we need is x plus something squared and y plus something squared. So to do that, we're going to need to use completing the square. Now remember, from completing the square, if you have a 2 in front of the x squared or 2 in front of the y squared in this case, what we need to do is first factor out that 2. What we do next is we're going to divide everything in this equation by 2. Okay, this is going to allow us to complete the square a bit easier. So I want this to be a perfect square involving x's. So remember, the number that goes in the brackets is half of b, half of the coefficient of x. What I really want is I want to make this into x plus 3 all squared. But x plus 3 all squared is x squared plus 6x plus 9. So what I need to do is add a 9 there. So similarly for the y, I want to make that plus y minus 4 squared. Why did I choose negative 4 of all numbers? Because it's half of negative 8. But if I expand y minus 4 all squared, I get y squared minus 18y, but then I need to have a 16 on the end. But hang on a minute, I can't just add 9 and add 16 to this side of the equation without changing it. So in effect, I've added 25 to the left-hand side, so I must also add 25 to the right-hand side. So that means I get 39 plus 25, which is 64. Now, this is in the right form of a circle. So the center is just the negative of the number in the x bracket, the negative of number in the y bracket. The radius is just the square root of 64, which is 8. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.